Alrighty, in this video we're doing induction with division. Most people find this easier than the first induction, so hopefully that's a bit reassuring. We're going to prove that 4 to the n plus 2 is divisible by 3 for every whole number that's bigger than 0. So let's check step 1. Usually this would be to check P1, but we're actually checking P0. I guess before I do this I should be like, let Pn be the statement that 4n plus 2 is divisible by 3. So yeah, step 1 is usually to check P1, but we're not starting at 1, we're starting at 0, so you could check P0. Therefore, 4 to the 0 plus 2 equals 1 plus 2, which is 3. Therefore, P1 is true. So step 1 is done. Now, if you want to, you don't have to do step 2 and step 3, but sometimes it's a nice idea to see what you're doing. So if you do 4 to the 1 plus 2, that's 18, which also works. And 4 squared plus 2 is going to be 64 plus 2, 66, so that also works. It looks like these are going to be divisible by 3, so that's nice. Step 2. Assume pk is true. Therefore, 4 to the k plus 2 is divisible by 3. And what I'm going to do, like, what does it mean for something to be divisible by 3? It means it's a multiple of 3. So I'm going to write 4 to the k plus 2 is 3 times some number a. Now, a has to be a whole number, so it's in Z. And we're going to label this as star because we'll use it later. Step 3, prove pk plus 1. So we'll do our want to show. Want to show that 4 to the k plus 1 plus 2 is divisible by 3. Alright, so let's do that. So if we look at 4 to the k plus 1 plus 2, this is 4 to the k times 4 to the 1 plus 2. And we know what 4 to the k, let's see, it actually helps if we write this bit rearranged. So 4 to the k equals 3a take 2, just like taking 2 from both sides. And essentially, we can replace 4 to the k with 3a take 2 here. So times 4 plus 2 still. Now this is using star. So yeah, these division proofs, it always helps if you rearrange it like that. Now we can just keep expanding and simplifying. So I might write this 4 out the front. We'll expand it in. So 12a take 8 plus 2, which is 12a take 6. And what I'm actually going to do is pull a factor of 3 out here. So this is 3 lots of 4a take 6. Now, the question is this divisible by 3? Well, 4a take 6 is a whole number. Therefore, this is divisible. Like, this is 3 times a whole number. Therefore, this is divisible by 3. What we say is, therefore, pk plus 1 is true. Therefore, by mathematical induction, four to the n plus 2 is divisible by 3 for all n greater than 0, n in Z. Done. Hopefully that was a bit nicer than the summation ones.